Here we're going to look at a sample problem for position, velocity, acceleration equations. So here we have a ball that's being thrown vertically upward with a velocity of 10 meters per second from a window located 20 meters above the ground. For pretty much every problem in this course, it will be appropriate, except for some of the pure math questions, it will be appropriate to draw a picture. So here we have a building. Let's say it looks like this, and we have a window here, and the ball is being thrown upwards with a velocity of 10 meters per second. So velocity, not the initial velocity, is 10 meters per second upwards, and that location is at 20 meters above the ground. Knowing that the acceleration of the ball is constant and equal to 9.81 meters per second down, so acceleration is equal to 9.81 meters per second downwards, determine the question is asking us for the velocity v and elevation y for any function of time. So they're asking us to say, they're looking for an equation, velocity of time, and an equation y of t. They're also asking for the highest elevation, and they're asking for the time when the ball hits the ground. So now we know what the problem's asking us for, and we have an understanding of what's happening, but we haven't set our origin or positive direction. So I'm going to set the origin here at the ground. So here y would be equal to 0, and I'm going to set the positive direction upwards. So that means that our acceleration is actually negative 9.81. So acceleration is negative 9.81 meters per second squared because it's going downwards. And it means that our y naught is equal to 20 meters because it's in the positive direction from the origin. And now we're ready to start solving our problem. We know the acceleration is 9.81 meters per second squared, and the question is asking for the velocity at any point t. So here we know acceleration is equal to dv over dt. So we'll plug negative 9.81 meters per second squared. We'll bring the dt up. dt is equal to dv. When we integrate this, we're going from time is equal to 0 to any point in time, because the question is asking us for an equation for any point in time, and our velocity is going from v naught to v. In this case, we know our v naught is equal to 10 meters per second. So when we perform this, we end up with negative 9.81 times t, because the lower limit will always be equal to 0, is equal to v minus v naught. Now we know that our v naught is equal to 10, so I can replace this with 10. And they want an equation for velocity, so I'll actually bring this value over here. So we have velocity is equal to 10 minus 9.81 times t. So that's our equation for velocity. They also want an equation for position, so then we know that velocity is equal to dy over dt. So we do exactly the same thing, except now we have an equation for velocity with respect to time that we plug in to here. So we end up with 10 minus 9.81 t, integrate over time from t is equal to 0 to time t is equal to the integral from y naught to y of dy. So then we have, when we perform this integral, you have 10t minus 9.81 t squared over 2, evaluated from 0 to t, I'll put brackets here for the whole thing, is equal to y minus y naught. In this case, because of the form of this, we can ignore t is equal to 0 because all the terms would go to 0. So then you just have 10t minus 9.81 t squared over 2 is equal to y, and our y naught was 20, minus 20. Since the question was asking for a function of y that depends on t, we'll rearrange this and we say y is equal to negative 9.81 t squared over 2 plus 10t plus 20. That is our equation of the position of the ball for any point t. The next part of the question is asking us to find the highest elevation. Now the highest elevation is going to occur, so P, the highest elevation, is going to occur when the velocity of the ball is equal to 0. How do we know this? Because if you think of a ball, and I'm going to draw this as if it was projectile motion, but the ball is going up, 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 and then it's at the highest point, then it's going to start going down, which means the velocity as the ball is going upwards, the velocity is bigger than 0. Right after that moment when it hits the highest velocity, it's going to start coming down, which means the velocity is going to be less than 0. And so there's going to be this point here at the very top where the velocity is equal to 0. So the max height of the ball will be when velocity is equal to 0. Now very conveniently, we have an equation for velocity. So we know that velocity is equal to 10 minus 9.81 t. So we're looking for when velocity is 0, so 0 is equal to 10 minus 9.81 t. And then we can solve for time. Time is equal to 1.02 seconds at max height. So now to find what that max height actually is, we use the other equation that we derived at the beginning of the problem, which is y is equal to negative 4.905 t squared plus 10t plus 20. And now we plug this t value into this equation at all of these points, and we end up with a value for y. Y is equal to 25.1 meters. So that's saying that the ball is shot upwards. Its original height was at 20 meters. It reaches a peak height of 25 meters, so the difference would be here 5 meters. And then it starts to come down until it reaches the ground. The last question is asking us to find the time when the ball hits the ground. So the ball is going to hit the ground here. Y is going to be equal to 0. So now we can plug in, using the same equation, y is equal to negative 4.905 t squared plus 10t plus 20. Now we plug 0 here is equal to negative 4.905 t squared plus 10t plus 20. And now we solve this quadratic equation. So the quadratic equation is negative b plus or minus b squared minus 4ac square root divided by 2a. If you plug these values in, you get t is equal to negative 1.24 seconds, or t is equal to 3.28 seconds. Since we can't have a negative time, this option is out, and time is equal to 3.28 seconds. This is when the ball hits the ground. If we want to know the velocity of the ball at that time, then the velocity is just equal to 10 minus 9.81 times t equals negative 22.2 meters per second. So this t value gets plugged into there. It makes sense that we have a negative velocity because we had set our origin here at the ground. The ball started here, it went up, and then it started to come down. So when it hits the ground, it should have a negative velocity here. It's really important to denote your positive and negative directions.